Okay, so what we're going to do right now is we're going to take notes over Chapter 2, displaying and describing categorical data. Some of you might have the handout, some of you may not. You will be able to write everything down if you need to. Okay, so a frequency chart table, what this does is it shows, shows counts, and this is just for one variable. The difference between a frequency table, change colors, and a relative frequency table is a relative frequency table shows percents, but it still just has one variable. Now, everything we're talking about today is only for categorical variables. So an example would be, let's say we took a survey of people's favorite colors, right? We got green, blue, red, and maybe yellow. Okay, let's say there was 5 that liked green, 8 that liked blue, 7 that liked red, and 2 that liked yellow. This is a frequency table. That's all it is. It's just being able to read the numbers with which category it is. If you need to turn it into a relative frequency table, because again, relative means percent. That's a big thing you got to recognize. You have to find out what each percent is out of the total. And so the total is 22. So it would be 5 out of 22, which we'll get the calculator in a second. 8 out of 22, 7 out of 22, and 2 out of 22. Okay, so when we have these percents, sometimes they'll add up a little bit past 100 or under 100. It's just going to be based on, my cat's in the background. Sorry, guys. It's just going to be based on maybe you rounded differently, but they should essentially add up to 100. Okay. And so you have to understand the difference between a frequency or relative and be able to make it if I give you data and you have to put them in piles. Okay. So a bar chart, it is a display that describes categorical data. The bars do not touch. You cannot have the bars touch. Same thing for this one. Bars don't touch here, but remember this word relative. We're going to look at things as percent. Okay, so you are going to have to make some graphs occasionally. You don't have to get super perfect about it. So we have our axis. The most that I have is 8. So we could actually do 1 each time. 1, 2, 3, 4, 5, 6, 7, 8. And on the side, I'm going to try and write on the side. You can either write the word count. I don't know if I can turn sideways. I can't write sideways because it's a computer. You can either write the word count or frequency. Okay, so this could either say count or frequency. The order does not matter. So I'm going to have green. And green should go up to 5. 1, 2, 3, 4, 5. And I center it around where it says green. And then I have blue. You cannot make these touch. If you make these bars touch, you're turning it into something that's not. This goes up to 8. And then we have red, which goes to 7. And when you have straight paper, it's easier. I'm also writing on this computer, which is a little tricky. And then we have yellow. But this would be full credit, right? I could see the bars are separate. You have the bars labeled, and I would be able to count to see where they're at. To do a relative frequency bar chart, instead of having counts on the side, you have percents. Okay, and so I still have green, blue, red, and yellow. Okay, so this one does have to go up to 36, right? I don't need that many tick marks. You can count by tens, but you notice these are about equal distance apart. So green is 23%, so I should notice that it goes past the 20, maybe not halfway. Okay, blue should go over halfway to the 40. Red should be a little bit above the 30. And yellow should be right below the 10. Okay, that's what I'm going to look up for. I'm going to look for, did you go past where you're supposed to? Did you go below where you're supposed to? I'm not going to really care unless it's a 32 and you put it up where 39 would be, right? I need to be able to judge it that way. Okay, it's kind of hidden here. A pie chart. I'm not going to ever make you make pie charts. Maybe on a computer I would, but by hand, no. A pie chart, it's a circle, obviously, but it must equal 100%. Pie charts, you can't have overlap, okay? You cannot have things overlap. So if you chose two favorite colors, it wouldn't work for a pie chart, okay? All right, so when you have data that overlaps, so let's say I ask what's your favorite ice cream, and I let you choose up to 3. That's something that can overlap because maybe you like vanilla, maybe you like cookies and cream, and maybe you like cookie dough, right? That's when things overlap. When things overlap, you must use a bar. Pie chart's not an option. If data overlaps, you must use a bar. Okay. One big thing we're going to talk about, and you probably just watched in your video for the notes or for the reading, is called the area principle. And the area principle is the most common place where people will make statistics lie. Right? It's the most common place for stats to lie. Okay. The way they do this is they change the scale on the graph. They change the axis on the graph. They mislabel things. They do all sorts of stuff like that. We'll talk about more pictures, but the big thing is you have to make sure your graph and charts are to scale. And so your axes need to go the correct way. Your axes has to be consistent. Okay, there's a lot of different ways, but the area principle is where data lies the most or where people misinterpret things the most. Okay, in stats, there's going to be a lot of times that you guys have to check conditions. And you have to check conditions so that you can either make inference or make charts or do different procedures. The first condition we have is called the categorical data condition. And all it says is that before you make a bar or a pie chart, you must check to make sure that the data are categorical, which is what the name says. Okay? Not much, just has to make sure that it's categorical. And when you have categorical, it can either be counts or percents. And remember, percents is that word relative. When you see something that says relative, that is percents. Okay, a lot of the time we're going to be spending this chapter is going to be on contingency tables. And a contingency table is a table, let's highlight that shows how individuals are distributed along each variable. So instead of having one variable, there's 2. So let's go back to our colors. This time I'm going to do them across this way. So green, blue, red, and yellow. And now what I'm going to do is I'm going to break it down not just by color, but I'm going to break it down by gender. Male and female. And this is people's preference. So let me go back and look at these numbers. So green, we had 5. So I'm going to say that 3 men and 2 women liked green. Blue was 8, 7, and 2. Blue, 6. Blue, 2 for female. Maybe only 2 red and 5 for female here. And then let's just say it's even here, okay? You're never going to have to figure out this. This is going to be in a table that you'll have, okay? This is called a contingency table. Now, there's a lot of different questions that I could ask here. And so this is where we get our practice. So we'll put some questions to the side. What percent of people were female? Now, one thing I want to make sure that I got to stress this. I'm going to make this huge. Let's make it big. Thicker font. You must show fractions. If you just give me a decimal answer, I'm marking it wrong. If you just give a decimal answer on the AP test, they will not give you full credit. You must show fractions. Okay? So, what percent of people were females? Well, 2 plus 2 plus 5 plus 1. That's going to be 10 out of, how many did we say? I forgot what we said. 32? 22. 10 out of 22. Okay? You don't even have to show the decimal. You don't even have to reduce, but you must have this fraction. Again, if you do not have that, it would be wrong. And I can tell you right now, this is probably going to be the one part of stats that's going to aggravate the most of you, because there's going to be times that I'm going to tell you that you have to write down 5 plus 3 because it's showing your evidence that you know how you got that answer. Okay. For number 2, let's say what percent was male that liked blue. Okay. And so this saying, out of this whole thing, what percent is the male that liked blue? Or male blue is right here. So it's 6 out of 22. You do not have to reduce fractions, but you do have to write the fraction. Okay, so a marginal distribution is the frequency of the distribution of one variable. So that means I'm looking at the whole variable. I'm looking at the whole row, or I'm looking at the whole column. Okay, and so we're going to do a couple so you can see. So entire row or column. Yeah, look at that horrible looking handwriting. Okay, so for number 3, what is marginal distribution for male? Okay, if you put it in the same order that the table's in, you don't have to identify it. If you notice here, you see how male is horizontal? If I write my answers horizontal, then it works. So let's see. So what you're going to do here is you are actually going to kind of ignore this whole row. Don't cross it off on your paper because I'm going to be able to delete that. But I'm going to just ignore that whole thing. And so what I'm focused on is I'm focused on only on male. And so the marginal distribution, there are 3 plus 6 plus 2 plus 1. So what is that? 12. So that's going to be 3 out of 12, 6 out of 12, 2 out of 12, and 1 out of 12. I put them in the exact same spot as they would fit in the table, so I don't have to identify them. You can leave them just like that. Okay, so let me delete that. Okay, so now let's look at another one, number 4. Marginal distribution of blue. So blue, this time, goes up and down. So that means I'm going to ignore everything else. I'm just going to look there. And so when I do that, that's going to give me the first blue is 6 out of 8, and then 2 out of 8. But you notice because it was vertical, I wrote the answers vertical. If you were to do this, unless you told me that this was male, so blue male and blue female, I would not give you credit. But if you keep it in the same spot, then I know where it's coming from. Okay? And I know there's a lot of little picky rules about stats, but if you learn them now, it's going to make it easier. Okay, so let's erase this stuff. Okay, we're going to erase the wrong one. Or you could put a line through it and slash it. Okay, so that's marginal. So marginal, think about it like the margins of your paper. On your paper, the margins are the whole bottom and top and the whole left and right. And so marginal is the whole row or the whole column. Okay, the next thing, and this is kind of tricky, is something called conditional. Conditional distribution. Hold on, I'm not drawing. Conditional distribution, come on, draw. Shows the distribution of one variable that satisfies a condition. Okay, a lot of times they're going to use the word given. And the difference between conditional and marginal, conditional is just going to be one fraction. Okay. All right, and so let's look at this. Let me move the mouse back up. We'll usually see numbers. Okay, so number 5. Given someone likes green, what percent are male? All right, so this is the important part, okay? And this is where it gets a little tricky. Do you see that it says given someone likes green? That means I'm only supposed to look at green. I only look there. I ignore everything else. I just look at green. So that's the all of green. All of green is 5. Out of this one, because I'm covering it up, if I was in class, I would physically take my hand and cover my paper. So out of that, the percent that are male is 3. So you have to look at the given part to kind of understand what you're crossing off. Okay, so here's another one. What percent like red, knowing they are female? So I have to focus on red and female, but you see how it says they didn't use that word given, but they did say knowing, right? So that means they have to be female. So that tells me this is all I look at. I don't care about the boys. We just look at female. Now, out of those, which ones are red? Well, that's this one. So the answer for this one is 5 out of 10. Okay, so we had to know. And now you see how it says percent? I still have to have a fraction. You're more than welcome to put a percent, but it must have a fraction there. Okay, the last thing we want to talk about in this video, and I know it's a little long, but it's the first one with lots of stuff to do. So the first thing is, our last thing is independent. Variables are independent in a contingency table when the distribution of one variable is the same for all of the categories. So let's say we have a table about house and apartments, and we're comparing pet ownership of dogs and cats. So when I do the percents, let's say the dogs is 38% in house and 20% in apartment. If having a dog was independent of the type of building you lived in, these two things would be the same. They're not the same. So having a dog and what kind of house you live in is not independent. Okay, cat, let's say 58% have cats here, and 58% have cats here. You see how cat is the same percent in house as it is in apartment? If it is the same percent, then that means that having a cat is independent of where you live. Okay? So if they're the same, it works. Okay? They must be exactly the same. So when you calculate these, if one is 8 out of 10 and the other one's 8 out of 11, it's not the same. It has to be exactly the same. So you have to have equal distributions when you look across the way. Okay, so there's a lot of different information about categorical data. This is about the only time we spend time on categorical until the very end of the stats textbook. Okay, so make sure you know how to read tables and interpret tables, how to make bar charts and interpret circle graphs. We're not going to make circle graphs. And then really the biggest amount of time and the trickiest stuff is down here, understanding marginal and conditional distribution.